Hi everyone, Professor Rosenthal here, and next we're going to take a look at further shortcut rules, this time those that involve trigonometric functions. Previously we learned how to take derivatives of things like of the form x to a power, constant multiples, sum or difference of quantities. We learned how to take derivatives of products or quotients, but we did not yet learn how to take derivatives of trig functions. For example, what is the derivative of sine x? What is the derivative of cosine x? Things like that. And here's where we're going to learn those. And after we learn those, you can apply all the other rules together with the trig functions. You could have a product of trig functions or a quotient of trig functions. So let's get started, beginning with the derivative of sine. So let me give you a few of these. First of all, later we'll come back and try to prove them. But let me tell you that the derivative of sine x turns out to be cosine of x. And if I ask you to take a guess, what do you think will be the derivative of cosine x? You might say maybe it's sine x, right? It would be a good wild guess, but the correct answer turns out to be -1 times sine of x. So that's the derivative of cosine. And all these other trig functions can be determined by using basically the knowledge that derivative of sine is cosine and derivative of cosine is negative sine. So for example, if I want to know what happens for the derivative of tangent of x, I can rewrite tangent in terms of sine and cosine. So tangent is sine over cosine. I hope everybody remembered that from their trig classes, right? And notice that is actually a quotient of expressions that involve a variable. So we can use the quotient rule of differentiation. So the derivative of this will be, we know the denominator will be whatever you had originally in the denominator to the second power. So cosine x quantity squared. For the numerator, we're going to have lower times derivative of the higher. So that's cosine x times derivative of sine x. Derivative of sine is cosine, minus higher, the one that appears on the top, divided by derivative of the bottom. So the higher one is right now sine x, times the derivative of the lower one is derivative of cosine, which is negative sine. So once again, we have low, d high, less high, d low, like lower times derivative to higher minus higher times derivative to lower, everything denominator squared, everything divided by that. But now notice you have two negative signs. So what do? You have negative sine x times negative sine x, so that's positive sine squared. So let's simplify this a little bit. Here we're going to have cosine times cosine is cosine square x minus, actually make that a plus, two negatives multiplied together is plus sine square x, right? All over cosine x to the second power. I can also write it like this, cosine square of x. And now I have an important question to ask you. Do you remember from your trigonometry classes the identity cosine square x plus sine square x equals something? Do you remember what that something was? Okay, so if you remember that as 1, you are absolutely correct. It's one of the most important trigonometric identities you learn in that class. So here we have 1 over cosine square of x. So let me write a reminder. So we're going to need to know this. Sine square x plus cosine square x is equal to 1. And there's a similar one that may come up later on. Let me also mention that one. 1 plus tangent square x equals secant square x. And basically you could take the first equation here, divide everything by cosine square, and you're going to have this identity. And the other thing we should remember is like reciprocal values, like secant x. In terms of sine and cosine, what is that? Remember it was like 1 over cosine of x? And while we're there, let's also remember cosecant of x. Do you remember that one? 1 over sine x. And one way I remembered always these is like S and C, C and S. You never have like S and S, like so secant is not 1 over sine. The initials are not going to match. if you have secant, it's going to be 1 over cosine. If you have cosecant, it's going to be 1 over sine. Okay, why did I go over that? Because over here, we want to simplify this 1 over cosine squared. First of all, what is 1 over cosine equal to? From over here, 1 over cosine is secant x, right? So now, but it's squared, so it's going to be secant square of x. So we just determined something important, that derivative of tangent function equals secant square of x. And these derivatives are going to be very important, especially if you take the entire calculus sequence. So I'm going to ask everybody to know at least the 4 of those, including the tangent. So I'm going to fill out this chart. Derivative of tangent is secant square of x. And the 4th one is the derivative of secant function, which we're going to take a look at together. And if you know those 4, you can get the other ones with a little trick I'll show you. Okay, so let's first go back and try to figure out what is the derivative of the secant function. Okay, it helps to rewrite secant, first of all, in terms of sines and cosines. In this case, it is 1 over cosine of x. At this point, let's use the quotient rule. Okay, so according to the quotient rule, so you take the lower one times the derivative of the higher. Derivative of 1 is 0, minus the higher one times derivative of cosine, which is negative sine. Everything divided by denominator squared. Now 0 times anything is 0. This part disappears. So, and then negative times negative will be positive. So here we have sine x over cosine x squared. Technically, that's the answer, but you're not going to see it in that format. So I'm going to kind of break it apart a little bit. This is same as sine x over cosine x times 1 over cosine x. Because think about it. If you were to multiply these back, for a product, you don't need common denominators. Just multiply the tops and multiply the bottoms, right? So you would have sine x over cosine times cosine, which is cosine squared. Now, what's the advantage of breaking it apart as a product of 2 fractions? Well, sine over cosine has another name, right? Tangent. So the first part is tangent x, and 1 over cosine x is another name, secant x. So again, this is what we've learned. The derivative of secant function is secant times tangent. You can say tangent times secant, but for some reason, everywhere you see this secant is written first. Let's see. Okay, so I'm going to go back and fill up our chart over there again. So where we see secant x, I'm going to put secant times tangent for its derivative. Secant x times tangent x. And while we're here, let me also tell you how to get the other ones easily. If you know the derivative of tangent is secant squared, to get the derivative of cotangent, what you do is you put a negative up front and you take the cofunction of this. So the cofunction of secant squared is cosecant squared. So now you know the derivative of cotangent. If you ever forget, you can go from basics, right? You write cotangent as cosine over sine, use the quotient rule. That's a lot of work. It's easier if you memorize tangent, and from there you can obtain the derivative of cotangent using the negative cofunction principle. Now let's apply that to this. Okay, if you know the secant function, okay, you know the derivative of secant function right here. Let's try to figure out the derivative of cosecant function. It's going to be negative cofunction of each of these on the right side. Cofunction of secant is cosecant, and cofunction of tangent is cotangent. And I'll be honest with you, I'm going to emphasize these 4 the most, the sine, cosine, tangent, and secant. But just every once in a while, and in case you need cosecant, cotangent, just know that you can also obtain them relatively easily. Okay, now that we know the derivative of 6 trig functions, we can go and do some mixed examples with them. But before we do that, I just want to point out to you, like, where in the world did they get the derivative of sine function? Well, how do we know that derivative of sine is cosine, right? That was just handed to us in the first page. But just to give you a glimpse of the proof, and we're not going to go into a lot of details, but everything goes back to the definition of a derivative, okay? If your function is sine, what would be your f of x plus h? It would be sine of x plus h, right? Minus f of x. So that's minus sine over h. Plug in 0 in the beginning, you have 0 over 0. That means you got to do something to simplify this. And that's when you will have to use certain identities you learn in trigonometry classes. Like, you remember the sine A plus B formula? Okay, that will come very handy here, okay? That's like sine x, here you have sine of x plus h. Sine x cosine h plus cosine x sine h. So this came directly from a formula from trigonometry. And then what we do is like we rearrange things a little bit. Like we put the two things that have sine x in it next to each other over here. And we put this one at the end. And then we factor the sine x from the first two terms. And notice limit is taken as h goes to 0, sine is factored outside, because sine doesn't depend on age. All you have to do is, what is this limit? Cosine h minus 1 over h. And if you could find that limit, and I already entered that into my Desmos here, here's my function, cosine h minus 1 over h. This one won't work if I enter h, I have to enter x, but same idea. And I get this function. What happens when h goes to 0? Basically, you're going to get the limit is going to be 0. So if you go back and plug in 0 for this limit, 0 times sine x is also 0. So the first part you get is 0. The second part, so you have a limit h goes to 0 sine h over h. You may remember from the past, it's a special limit. The limit is 1. So now you have 1 times cosine x plus 0. So there we have it. I know this may have been complicated and I went over it super fast, but I just want to show you the idea, even if you may not understand every step of this proof, the idea that every time we see a new rule about derivatives, chances are it's going back to the basics, to the foundational rule about how to take the derivative from the definition, this rule right here. And also I want to point out to you that sometimes, rules that you think are, oh, so pointless, you're getting bored in trigonometry, learning these endless formulas. Well, as you go in higher levels of math, you might be surprised how much those are used. Like in this situation, if we didn't know sine of x plus h, we couldn't perhaps end up with the derivative of sine x being cosine x. So those formulas are helpful, but sometimes it takes a long time to see where they're helpful, right? Okay. And next we're going to look at a few examples. All the rules about derivatives still do apply. We just have to also now use our knowledge about trigonometric functions. So for example, if y equals x cubed plus 5 sine x, let's go ahead and figure out the derivative of that. So derivative of x cubed is 3x squared. There is a plus in the middle. So I put the plus, and the derivative of 5 sine x, that's a constant multiple, the 5 remains, and derivative of sine is cosine. So that's my answer. Y prime equals 3x squared plus 5 cosine x. Now, we've not seen y double prime, but all that means is the second derivative, and to find that, you just take the derivative of the first derivative. So if you were to differentiate this one more time, what would you get? So derivative of 3x squared is 6x. And derivative of 5 cosine x, okay, derivative of cosine is negative sine, so it'll be minus 5 sine x. And you might ask, is there any applications of the second derivative? We've seen applications of the first derivative, and the answer is yes. I'm not going to get into too much of it right now, but we're going to learn later on, like we can find acceleration using the second derivative of distance function. You can find information about concavity and inflection points, but right now we don't have to worry about it. Just they said find y prime, find y double prime. You don't have to do that for every question. Only if they ask us to do it, then we take the derivative for the second time. What about the next one? Just y prime. So if y equals 6x squared, y prime is 12x, and 6x squared minus sine x is the original function as a matter of fact. So the second term, the derivative of negative sine x will be, keep the negative, derivative of sine is cosine, so there's our answer, 12x minus cosine x. Okay, what about something like tan cosine x minus 5 tangent x? As long as you have a sum or difference, That's the easier question because we know we can distribute our differentiation operation over a sum or difference easily. We go one term at a time. So 10 cosine x, the derivative will be negative 10 sine x, right? And negative 5 tangent x. And what do we know about the derivative of tangent? Feel free to refer back to your formulas at the moment, but by the quiz, by the time you take the quiz on this topic, you should really know them by heart because you're going to need them on the test. And the only other way is like to derive them every time, but that would be very time consuming, okay? So derivative of tangent is secant square. So now we have y prime equals negative 10 sine x minus 5 secant square of x. Okay, take a look at the next one. Okay, this time we have a product, right? X times cosine x. So now we need to write, take the derivative using the product rule. So according to the product rule, you write the first one times the derivative of the second. Derivative of cosine is negative sine x. Plus, write the second one, cosine x, times the derivative of x. And derivative of x is 1. So that's our answer. And we cannot really simplify that all that much. Negative x sine x plus cosine x will be our final answer. And don't even try to multiply these two. The values outside of sine cannot be multiplied by the values inside of sine, right? We got to leave it exactly like that. Okay, number 5 should be easy because once again you have a plus in the middle. So we're taking the derivative of 5 tangent t plus 3 secant t. So that will be 5 secant square of t plus 3. Okay, do you remember the derivative of secant function? Okay, look it up if there need be. Secant times tangent, right? So 3 was already there. 3 times secant of t times tangent of t. All right, the next few are going to be a little bit more challenging because again, we're getting into quotient rule, product rule, and we may have to remember certain trig identities to simplify some of our answers. So for example, let's take a look at cosine over 1 plus sine. That's number 6. Okay, so for that one, if you said quotient rule, you're absolutely correct. We're going to apply the quotient rule. Okay, take the lower quantity times the derivative of the higher, which is negative sine. Remember there's a minus sign for the quotient rule, minus. Take the higher quantity, cosine x, and multiply it by the derivative of the lower one. Remember, derivative of 1 is 0, and derivative of sine is cosine, so we're going to multiply it by cosine x. Everything divided by the bottom one quantity square. So it's quantity squared to 1 plus sine x. Now for the top, I'm going to try to simplify it. So distribute the negative sine x first. Negative sine x minus sine square of x. And at the end we have minus cosine times cosine, so that's minus cosine square x. Do not forget the denominator. It's still there. And we see here a different version of the sine square plus cosine square equals 1 formula. What do you think will be negative sine square minus cosine square? Like you could take out a negative 1 from both of them, right? And then you're going to have negative 1 times on the outside sine square plus cosine square, which is 1. So that will basically become a minus 1, this whole thing. So here we have negative sine x minus 1. So the rule that we're using there is negative sine square x minus cosine square x equals negative 1, because I can factor negative 1 out of both of them, and I'm going to be left with this. And the inside part is 1, so you got negative 1. Okay. And the bottom is 1 plus sine x quantity square. The question is, can we simplify it further? Because usually I'll ask you to leave the answer in the simplest possible form. And I could take out a negative from both of the top terms. So negative 1 times sine x plus 1 over 1 plus sine x quantity squared. And now you might see, yes, we will be able to simplify it further because one of those 1 plus sine x from the denominator can be canceled with 1 plus sine x from the top. And don't forget the negative sign remaining. So our final answer is negative 1 over 1 plus sine x. Okay. All right, I think I'm going to go over the next few examples in another segment, but this gives you an idea about how to get started on finding derivatives involving trigonometric functions.